All right, welcome to Main Number Corner. Couple things that I want you to get ready for as we're going through Number Corner this month. We'll need a calendar collector sheet, which is something that you'll either create in your math notebooks or you can have an electronic copy shared. You can even create an electronic copy. It's not anything special. I just made a table in a Google Doc, which is something very easy for many of you to do already. um, that calendar collector. We're going to collect more liquid, but this thing's going to be called 2 quart filler spill. A couple of months ago, we did 2 liter filler spill. Um, so hopefully, when we get to that activity, we're kind of familiar with this. We're not going to do anything with it today. Just wanted to make that aware. Um, the other thing is our calendar grid. So we'll have our markers set out each month so that um, we can add to our calendar grid. That calendar grid is going to be a meadow grid, which is a coordinate grid, which will work on following moles through a meadow, which is this is the meadow, and we'll be marking nesting places and feeding areas for each of the nesting places. So this is located in your Number Corner book, so it's not anything that you have to print off, but I do have it available electronically if it's something that you need. All right, so let's take a look at what is on for day one. Problem strings. So this problem string is our 28th problem string for Number Corner, our like 1 millionth and 4 um, problem string in Bridges this year. Just does seem like we get slammed with a lot of problem strings, but I do think it's a great skill for us to kind of look back at it and use previous work to help us solve problems. So you're going to need your notebooks. Make sure that you have a clean piece of paper for problem string 28. And we are going to be working with multiplication of fractions. We've been doing a lot of this. We did it last unit in Unit 6. Some of you might currently be in Unit 6 still, or even in Unit 5. That's okay. It's just going to be a review for most of us, and we're going to go and get started. So in our first problem, we're supposed to take 1/5 times 1/3. Now, what I've already done for you is I've already taken a rectangle and I've divided it into fifths. There are 5 equal or mostly equal parts here. And then if we're doing an array method, right, our 1/5 would be written across the top, and down the side, we would have to divide our rectangle into thirds. So when we're looking at this, we need to kind of consider, where do our fifths and thirds overlap? So if I'm looking at 1/5, I would shade in this whole section right here, because this is 1/5. Oh, I can't do that. This is 1/5 right here, right? And then I would look at my 1/3 and I would shade in this section up here on the top, because this is 1/3. And then in your mind, you got to kind of look and ask, how many of those squares do we overlap in? And if I'm shading in this section here and I'm shading in this section here, I'm only shading in one, or I only have an overlap in one of those pieces. Now, the answer, or our denominator, is one of all of these pieces. So that is going to require a little bit of math or counting. 3 times 5, which is 15, and you get 1/15 for your answer. So now go ahead and do the next problem in your notebooks. Shade in again 4/5 and look at 1/3, and what is your answer? All right, very simple, right? I would shade in 4/5, so I'm shading in 1, 2, 3, 4 pieces. I'm not shading in this piece here. I'm only being asked to shade in 4/5, and then I'm asked to shade 1/3. So if I shade all the way down through here, now I'm looking at places that I have overlapped in my shading. and I see that I've overlapped in 1, 2, 3, 4 of my pieces. 4 out of 15, correct? Now let's consider this a math problem, right? 4/5 times 1/3. Do you notice 1/5 times 1/3? Do you notice any correlations between our numerators up here and our numerators up here and our denominators here and our denominators here? I noticed something, but I'm going to do a couple more problems to see if maybe it continues to follow that same pattern. All right. So the next problem, go ahead and stop the video and show what 4/5 times 2/3 would look like. Start the video when you are ready to begin. All right, so if I take a look at 4/5 and 2/3, well, I know 4/5 and 1/3 is 4/15. So I'm going to assume that it's just double. So I'm going to make that 8/15, but I do want to prove it here. So I'm going to shade in my 4/5 again, but now 2/3, I'm going to shade in 2 of my rows here. And as I look, I notice that 8 pieces were overlapped in my shading. So it would be 8/15. And again, look at the numerators and how this numerator is related, and look at the denominator and how this denominator is related. You should be noticing some sort of pattern. All right. So now I go 4/5 times 3/4. 4/5 times 3/4. Well, I can do the 4/5, but I can't necessarily go 3/4 because I have 2/3. I have broken into thirds. So I'm going to have to adjust my lines here. I have to add another line and divide it into fourths. Everybody see that? Now what happens? How does that change my answer up here? Well, I'm still going to fill in 4 of my fifths, and I'm going to fill in 3 of my fourths. And where does it overlap? It overlaps in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It overlaps in 12 of the, it's not 15 because I've now added another group, or I've added another division here. It's 12 of the 20. Okay. Now, how does our numerators, or how do our numerators relate to this numerator, and how do our denominators relate to this denominator? Hopefully you can tell. All right, so now last problem of our problem string. Look at 2/3 and 3/4. Well, a part of me is already divided up into fourths, so I have to find some way to divide my shape, or my my rectangle, into thirds. Would you agree that that's how it is? So now I have thirds and I have fourths. Good. So I have 2/3 that I'm shading in and 3/4 that I'm shading in. So where is my overlap? 1, 2, 3, 4, 5, 6. I have 6/12, or half of my whole shape. And again, look at the numerators. How do they relate to the 6? And look at the denominators and how do they relate to the 12? Good. I'm hoping that you're noticing that when we multiply the numerators together, we actually get our answer, our numerator and our answer. And when we multiply our denominators together, we get our answer as a denominator. Okay, I hope that helps you answer how to multiply fractions. Go ahead and use the array method if it still helps. If not, if you don't need to draw it out anymore, just go ahead and multiply your numerators and your denominators to get your product. All right. If you have any questions, go ahead and contact and reach out to your teacher. If you don't have any other questions, have a great day and enjoy math.